This is 6.6, determinants in Cramer's rule. So there's two things we want to do. First of all, we want to evaluate determinants for a square matrix. We're going to do this for a 2 by 2, and then we're also going to do this for a 3 by 3. And then the second thing we want to do is use Cramer's rule to solve a system of equations. And Cramer's rule involves determinants. So once you learn how to do a determinant of a matrix, we're then going to apply that in something called Cramer's rule to solve the system of equations. Here's a matrix, A, B, C, D, and to find its determinant, you notice that the determinant is kind of matrix looking, but it uses almost like absolute value symbols. So instead of the matrix symbols, which are hard brackets or square brackets, it uses this kind of absolute value notation. And the numerical value of the determinant is calculated this way. You take A and you multiply it by D, that's A times D, and then you take B and you multiply it by C, that's B times C, and you subtract those two. Here we have the matrix square root of 3, negative 6, negative 2, negative square root of 3. So the first thing we're going to do is you change the matrix notation to the absolute value notation. We're going to take the square root of 3, multiply it by the opposite of the square root of 3. That's this step. And then we're going to take negative 6 and multiply it by negative 2. That's the step. And then we're going to subtract those two. And negative 3 minus 12, negative 15. So this is Cramer's rule for a 2 by 2 system of equations. So we have equation 1 and equation 2. And if we wanted to write them in a matrix, it would look something like this. A1, A2, B1, B2, and then the equal sign, and then C1, C2. And we would call this an augmented matrix. It's augmented because this part is the coefficient matrix, and this part is the constant matrix. In order to find the solution for x, you take the determinant of the x matrix, which we'll talk about in a little bit, and divide it by the determinant of the coefficient matrix. That's what this is. This is the coefficient matrix. And then to find the y-coordinate, you take the determinant of the y matrix, which we'll discuss in a little bit, and you divide that by the coefficient matrix. So to find the determinant of the x matrix, you take the coefficient matrix and you replace the values of the x column with the constant matrix values. You do the same thing with the determinant of the y matrix. You take the values in the y column and you replace them with values from the constant matrix. All right, so we're going to run through an example. So here we go. We're going to solve these using Cramer's rule. First thing you want to do is take these equations and put them into an augmented matrix. D is equal to 3, 4, 7, negative 5. D of x equals, you're going to take the x values from this column and you're going to replace them with the values from the coefficient column. So the determinant of the x matrix is 1, 31, 4, negative 5. You do the same thing for the y. The 3 and the 7 stay, and you replace the y column, 1 and 31. To find the x-coordinate, you take the determinant of the x part of the matrix, the x determinant, and you put that in the numerator. And then you take the determinant of the coefficient matrix, and you put that in the denominator at your x-coordinate. To find the y-coordinate, you do the exact same thing, except for you use the y determinant instead of the x determinant. And so your solution is the ordered pair, 3, negative 2. So for 3 by 3s, now we've got 3 equations and 3 variables. The fundamental idea is the same. You're going to find the determinant of the x matrix, and you're going to divide that by the determinant of the coefficient matrix. Then you're going to find the determinant of the y matrix and divide that by the determinant of the coefficient matrix. And then you're going to find the determinant of the z matrix and divide that by the determinant of the coefficient matrix. This is your determinant of the coefficient matrix. For the x matrix, you're going to replace the x column with the coefficient column. For the y matrix, you're going to replace the y column with the coefficient. Let's put this into a matrix. An augmented matrix. We need to find 4 matrices. Coefficient matrix determinant, the x matrix determinant, the y matrix determinant, and the z matrix determinant. D is going to equal the determinant of 1, negative 2, 3, 1, negative 1, negative 1, negative 1, 2, 1. Now when we had a 2 by 2, you multiplied the diagonals and then subtracted them. Well, you're going to do the same thing here, but there's just a lot more diagonals to multiply. You have to multiply every diagonal, every grouping of 3. And this looks kind of complicated, so I'm going to show you a trick. Watch this. So take the first column and write the first column out here. 1, 1, negative 1. Then write the second column out there. And now this is what you're going to do. You're going to multiply 1 times negative 1 times 1, negative 2 times negative 1 times negative 1, 3 times 1 times 2. So 1 times negative 1 times 1 is negative 1, plus negative 2 times negative 1 times negative 1 is negative 2, and 3 times 1 times 2 is 6. Okay, so that's the first grouping of diagonals. Subtract from that these diagonals. Negative 2, 1, 1, 1, negative 1, 2, 3, negative 1, negative 1. 1 times 1 times negative 2, negative 2. 1 times negative 1 times 2 is negative 2. 3 times negative 1 times negative 1 is 3. So the first grouping of diagonals gave us these values, which we added together. The second grouping of diagonals gave us these numbers, which we're adding together. And then we're going to subtract those two quantities. So D is equal to 4. So if we look back at this idea up here, for x, y, and z, there's going to be 4, 4, 4 on all of those. That's the denominator. And now we're going to do the exact same thing 3 more times. For the x, because we're doing D of x, we are going to replace this column, the x column, with the constant column. Or our first column will be negative 14, 0, 2. The other two columns stay the same. Now, find the determinant. So we're going to use the same trick. Let's write the first column out wide, and we'll write the second column out wide. And now you're going to, starting in the upper left, you're going to multiply 1, 2, 3 diagonals that way. So let's do that. Negative 2, 0, 1, negative 14, negative 1, 2, 3, negative 1, 2. 18 minus 22, negative 4. The x-coordinate is equal to d of x divided by d, which is negative 4, divided by 4, which is negative 1. D sub y, so that will be the matrix 1, 1, negative 1, negative 14, 0, 2, 3, negative 1, 1. And it's important to note that we replaced the y column with the constant column. So let's find the determinant. We're going to put a 1, 1, negative 1, negative 14, 0, and 2. 1 times 0 times 1, negative 14 times negative 1 times 1, 3 times 1 times 2. Negative 14, 1, 1, 1, negative 1, 2, 3, 0, negative 1. That's an 8. So your y-coordinate is equal to d sub y over d, which is 8 over 4, which is 2. D sub z. So the matrix will look like this. 1, 1, negative 1, negative 2, negative 1, 2, negative 14, 0, 2. Again, we're replacing the z column with the constant column. Find the determinant, so we're going to use this trick. 1, 1, negative 1, negative 2, negative 1, 2. Beginning in the upper left, 1 times negative 1 times 2, negative 2 times 0 times negative 1, negative 14 times 1 times 2. Negative 2, 1, 2, 1, 0, 2, negative 14, negative 1, negative 1. So the z-coordinate is equal to negative 12 divided by 4, which is negative 3. So our final answer is the ordered triple negative 1, 2, negative 3.